Hello everyone, this is Alamgir Hussain. Today we are going to discuss about impressed current cathodic protection on board ship. To understand impressed current cathodic protection, at first we need to understand what is galvanic corrosion is. So galvanic corrosion is when two dissimilar metals are submerged in electrolyte. One will become anode and one will become cathode. Anode ion will break due to potential difference with the electrolyte, causing electron flow. Thus current will flow from anode to cathode. And anode, you can see it's a sacrificial anode also, because it's being sacrificed itself to protect the cathode. So I provide an image. You can clearly see from that image that this anode is being corroded and cathode is being intact. So which one will be anode and which one will be cathode? It depends on the galvanic series. I have provided a galvanic series here. For example, you can see clearly magnesium, zinc, mild steel, wrought iron, cast iron, etc. etc. If I put magnesium and zinc or magnesium and cast iron in an electrolyte, magnesium will become anode because it is a more active metal in a galvanic series, and cast iron will become cathode. Thus magnesium will sacrifice or corrode itself up due to potential difference with the electrolyte, and thus saving the cathode. That means the whole idea of the iccp is to make the hull, ship's hull, cathode, to prevent itself from corroded. So we can clearly say that cathodic protection is a system of preventing corrosion by forcing all surfaces of ship structure to be cathodic by providing external source of power, external source of anode or external current, whichever you say. So how do we do that? How do we make the ship's hull cathodic? Here, to understand that, first we can see here I have put an image iccp applied to simple corrosion cell. That is a simple corrosion cell. One anode, one is cathode. Both are submerged in electrolyte. So our target is to make this anode cathode. And how do we do that? We have an current supply here, and that current supply is connected with the impressed anode. Through this anode, we supply current to the electrolyte, reducing the potential difference with the electrolyte and between electrolyte and anode, making this anode cathode and being protected. That's the idea of iccp. I have put a simple schematic diagram of iccp. You can clearly see from that here. We have one reference cell. We have power supply unit. Here is I have this power supply unit is 500 ampere. That ampere, how much power we need, it actually depends on the weighted surface area of ship. Larger the ship, more current we require, because our weighted surface area of the ship will increase. And with the weighted surface area, we also need the size of the propeller, size of the rudder to include total power supply unit required. And depending on the power supply unit, we need the anode capacity. We can decide how much capacity of anode we need by calculating for ship's weighted surface area, propeller and rudder size. So come back to the reference cell. This reference cell is made of zinc. Normally this reference cell actually measured the potential difference of hull in response to the electrolyte or seawater, and it measures the potential difference, gives a signal to the power supply unit. How much current do we need to supply to make the hull cathodic or to prevent corrosion? Each this reference cell gives us that signal, that how much current do we need to supply. After receiving signal from the reference cell, power supply unit decide and supply power to the strap anode fitted port and starboard sides of the ship. What it actually is doing the same thing here, providing current flow through the anode in port and starboard side of the ship. So it's providing current to the around the ship's hull, the electrolyte, that means in the seawater, and reducing the potential difference of hull with the seawater and making the hull cathodic. That is the simple and fundamental formula of iccp, impressed current cathodic protection. How it works and how it's operated, now we can clearly understand from that. So I hope you now understand the working principle of iccp. And I want to add some other thing is that in iccp normally we supply 440 volt, and through transformer and rectifier we get 24 volt dc. And current capacity of iccp is actually depends on the weighted surface area of the ship, size of propeller and rudder. I have shown you some pictures in my previous slides to make you understand the iccp, and in this picture current was showing 500 ampere. It can vary from ship to ship, I mean according to the size of the ship. So now we will move to the bonding and shaft earthing. And what is bonding? This bonding and shaft earthing is associated with the iccp. If your ship have a iccp, you must have this bonding and shaft earthing. Okay. So this what is the bonding? Bonding is to enable the rudder to receive protection. It is provided with a dedicated electrical bond in the form of a flexible cable from top of the rudder stock to the main ship structure. That is called bonding. That means the bonding is necessary to ensure the rudder is under protection of iccp. As rudder is connected to the ship's hull through rudder carrier bearing, there is a possibility of potential difference between ship's hull and rudder, and to minimize this potential difference we just through a flexible cable we just connect the rudder stock to the ship's hull, and that ensures the proper protection of the rudder. And now what is the shaft earthing? Shaft earthing, there is mainly three reasons for the shaft earthing on board ship. And the now what is the shaft earthing? When a propeller is turning, uh, there is lubricating oil film is created around the shaft. As we know, we have a stern tube lube oil system on board ship. This lube oil is constantly supplied to the stern tube sealing arrangement. So when propeller is turning, there is lubricating oil film is created around the propeller, and propeller for a stern tube sealing arrangement we have the seals. Seals are normally made of the non-conductive materials. That means there is a potential difference between hull and shaft, and this potential difference can accelerate corrosion in the ship or in the propeller. Okay. So and another reason for this shaft earthing is that if this potential difference between the shaft and hull increases, it can cause a heavy current flow in the bearings when oil film breaks down or is contaminated with the seawater. And this current can cause deep pitting of the bearing surfaces, stern tube bearing surfaces. An excessive of the shaft bearing can often trace to this cause. That means if a stern tube bearing have excessive wear down, this can lead to the improper shaft earthing. Okay. And number three reason for the shaft earthing is that to prevent the spark erosion on board ship. We will discuss about the what is spark erosion in later some other videos. Now this spark erosion is simply we can say that it is a small welding, and it happens when there is a shaft earthing is not working, or you don't have shaft working or shaft earthing on board ship, and there is a potential difference between shaft and hull increases. This current can flow through the bearings, through the shaft and through the crankshaft and bearing, and it can cause very small welding in the bearings, and this can lead to a catastrophic disaster to the main engine. So to prevent this spark erosion, shaft earthing is essential. Now, you have a shaft earthing on board ship, you have a millivolt meter. And how do you know your shaft earthing is working or not? Well, if your millivolt meter showing 0 at rest, it is in normal condition. At rest it can show 0 because there is shaft is not rotating. That means there is not oil or no oil frame around the shaft, and it is normal. But when shaft is rotating, if the millivolt meter showing 5 to 50 millivolt, that means you have a good shaft earthing. If this millivolt meter is showing more than 50 millivolt, that means your slip rings and brushes, slip rings and brushes needs cleaning, or your shaft earthing device needs overhauling. If this shaft millivolt meter showing 0 when shaft is running, you have, that means you have a faulty millivolt meter. You need to repair this millivolt meter, right? So that's it. I hope you understand what I was trying to say, and I hope you understand the working principle of ICCP bonding and shaft earthing. Thank you very much.